So today what we are going to do, we are going to learn about mid server. And in this session, we are not just see that how mid server is installed. Not just that part. We are also seeing that what are the different components in a mid server, how mid server actually communicates with ServiceNow, and how we can fine tune and have a performance things related to mid server, and what are the different components that we can utilize in a mid server instead of just having discovery, orchestration, and other stuff. Okay, so when I talk about mid server, so mid server is what? Mid server is a Java application that we installed on a server, or whenever I say server, your server can be any Windows machines or any Linux machine, which actually helps to have a communication with ServiceNow instance so that ServiceNow can execute any kind of commands in customer local infrastructure. Okay, so if you see this diagram, okay, if here's my pen, here's my laser. So if you see this diagram, so here what I have done is I have ServiceNow instance on the left. This is my customer environment. Okay, this is my customer network. Now here are certain routers, Windows machine, Linux machine, and it can be any n number of machines. Now, if ServiceNow has to communicate to these machines, because of enterprise firewall network and because of security, no one in an organization will allow any kind of inbound communication. So this mid server helps with that aspect. So when we install a mid server, consider mid server just a Java application, that this application is installed and this is communicating to ServiceNow via outbound connection over 443. So whatever the network options we ask to be opened on firewall and proxy, it is on HTTPS 443. Now, this is how it communicates in a high term. These are the generalized components. We will see that how all the things can be done, how they communicate, what are the different components, that we will come into later part. This is in general a higher picture that mid server will always be installed in customer premises. So all the controls, everything will be in customer premises. Okay, every control will be in customer's hand. Nothing can be controlled via ServiceNow apart from some of the properties like upgrading the mid server, what will be the certain properties while working with discovery, all those things. But other than that, all the security aspect, all the security parameter, all the OS hosted security aspect will be controlled by company. Now, so in this diagram, I try to show you that where our mid server can be utilized. So let's say this is my mid server 1, this is my mid server 2. Now ServiceNow, here is my ServiceNow. Now in ServiceNow, there are multiple applications that can utilize mid server. So let's say I want to have the discovery for these desktops, routers, Windows machines, Linux server. Okay. So what ServiceNow will do, ServiceNow will get all these information into the instance via help of mid server 1 and mid server 2. When mid server 1 and mid server 2 will execute those commands, then only we will be able to get this data, and those data will be passed through firewall and proxy. So there are two different aspects when I say firewall and proxy. Firewall allow the outbound communication to 443. When I say proxy, proxy is something that allow to have a outbound internet communication. Okay, so we will talk about certain prerequisite to set up the mid server. We will talk about certain other aspects that what needs to be done, what type of minimum configuration we need to have to set up the mid server. But this is generally how we need to have it. Now let's say an organization is also having a AWS and Azure or cloud components. So in that case, we need to install the mid server either in that cloud component, or if let's say the organization has restricted these AWS and Azure as based on IP restriction, that they will be only accessed via customer network. So in that case, we can utilize these existing mid server based on the type of data or based on the performance, or if we require to have, we can have a different machine acting as a mid server. Okay. Now, what we have seen till now is that how where mid server will fit into the picture. What are the mid server configurations? We need to first understand that. So, three important prerequisites are recommended, that is outbound connection to port 443 to ServiceNow instance, access to install.service-now.com at 443. Reason is why we require access to install.service-now.com at 443, basically mid server auto upgrade. So once you have installed the mid server, that is okay, but what will happen once your ServiceNow instance upgrade or there are certain patches? So mid server also needs to upgrade. So to upgrade the mid server, it try to download those jars or those information update files from this machine. So this needs to be provided. If it is not given, then you have to manually download the mid server again, and then you have to again install it, which is not a best practice. Another thing is, starting from a few newer releases, what ServiceNow has done is ServiceNow has created a certificate, okay, on mid server, a signing key. To validate that signing key, to have that validation on that signing key, access to OCSP trust server needs to be provided from mid server. It's again outbound 443 communication to this known server's API, so that certification validation can be done. If it is not provided, then we have to then we have to put a flag into a mid server and into a service now that do not test this or do not try to test this. Otherwise, what will happen? Every time you will try to install your mid server installation will fail. Now, here is one of the some of the prerequisite that we have written based on the product size and based on the thread values. Okay, so let's say by default standard is 25 thread, and when we talk about standard, in a standard you can do discovery, service mapping, and event management, and you require mostly space is 40 GB and the memory is again 5 GB, but again that will depend that what kind of applications you are utilizing, and there are multiple other factors that how many devices you are having, and that will come into the picture that how many mid server you might need to have. Okay, probably instead of 25 threads you can go up to 200 threads, then this will increase, because in that case you require more JVM, in that case you require more memories. Okay, another good important part is that when you install the mid server, you can install more than one mid server onto one machine, and the machine that we require for installing a mid server, that can be a virtual machine, or usually we prefer it to be a virtual machine. Okay, now when we talk about a single mid server, and these are some of the stats while we are having a discovery, but I'll just try to give you a simple thing. So let's say we have a single mid server. So to discover one IP, it will usually take 90 seconds. Okay, to discover one IP, it will usually take 90 seconds. If let's say we are having class C network where you are having 254 IPs, that will usually take 13 minutes, but it will depend on what kind of configurations you are having, what kind of different aspects you are having in a mid server. If let's say you are having only one single mid server where you are doing all the things, then this number might change and this number might increase. In case of class B network where you are having 16K IPs, it will usually take 6 hours. So when you are driving your mid server placement, you ask them if they are how many class B networks they are having, and if you are having many class B networks, you know that because of one component you are having, you might need to have 2 or 3 more mid server working in a different aspect. Now there are certain other things, okay, where we require high resource utilization. That is if you are having CMP, cloud management, or event management, basically RC and alert aggregation, and operational intelligence. Probably I'm not sure that how many of you know the OI component, but when we will talk about this OI component, that you will come to know that how many more resources, more stuff it usually utilizes. Okay, so we might need to have more mid servers, we might need to have high powerful machine to install the mid servers in case of these applications are in picture. Okay, now till now what we have done, we try to understand what mid server is, we try to understand the mid server prerequisite configuration and some of the threats to understand that how and when and how much time it might take usually. Now, when I say mid server, how we will come to know that at which situation we have to install a mid server, we have to use a mid server, and we don't have to use a mid server. Okay, so some of the examples I have written here in this slide, that when to use the mid server and when not to use the mid server. So let's say there is a client which wants to communicate with the system, and that is not on internet facing, and that system is residing in customer premises. Okay, then you require a mid server to have a communication. Or even let's say you don't have a device in customer premises, but you want to play with some of the ServiceNow application like discovery, service mapping, orchestration, CSD, even SAM, and even some of other applications are right now emerging. Then you require a ServiceNow mid server to be placed. Another good question come into the picture, when not to use the mid server, or what all the use cases when mid server should not be used. One is because mid server is a middleware component. Okay, some of the people think that okay, if there is a device which needs to call to a ServiceNow API, then we can call it via mid server. No, mid server is not a proxy server. Okay, though it's a kind of a proxy server for ServiceNow, but it's not a proxy server. Mid server can be used only from ServiceNow, not vice versa. You cannot do that you have an internal component which needs to call the ServiceNow API and you can call that API via mid server. No, you cannot do that. Okay. Now, mid server cannot do LDAP authentication. Okay, when I say LDAP authentication, it's not like in a mid server when I am having a LDAP S, basically there is a typo. So when I am having a LDAP S, I cannot use LDAP S as a authentication protocol. I cannot use. So it is something like that. When I need to use a AD based authentication, LDAP based authentication, not SSO, then in that case, I cannot use mid server to grab the data from my AD or from my LDAP. Another important one that I missed deliberately is file based or LDAP S based import set. Though this restriction is going to be removed in QBAC, but just for the sake that till now, if any one of you is working on Paris, there is still this condition that you should not use the mid server. Now, when I say mid server, okay, when I say it's a Java application, and we all know that it continuously keep syncing with ServiceNow. So how it do that? How it keep syncing with ServiceNow? So when I said when keep syncing means ServiceNow put some job and it immediately start and execute that job. How it is doing that? So there are two things in a mid server when I talk about. So that application. So let's dissect the application right now. There are two things. One is monitor. So this monitor, it keeps periodically, it runs on a timer and it see that if my mid server is up and running. Okay, this monitor comes from ServiceNow side. Okay, and it also check for the auto upgrade. Now, this is monitor part that will always happen on ECC Queue. Another is worker part. Okay, let's say ServiceNow wants to execute something, then it will go into the worker thread. So these are the threads. So you remember that we talked about that there are a standard thread of 25, right? That's the standard number in a mid server. So those are the 25 threads, okay, that a mid server can execute at a single point of time simultaneously. So those workers are nothing, those are threads. That mid server is having those 25 threads looking into all these worker threads. That is, if there is any job for me, if there is any job for me. Now, we have talked about all these things, okay? But still, all these things are what I say, theoretical, correct? We need to see it, we need to see that how things work into the picture. We need to see that how things work in real life scenario, correct? Now, when I say that mid server is a Java application, so it means I can install it anywhere, correct? Actually, I can install it on Windows and Linux. Mid server yet not support your Mac machine, okay? But there are multiple ways you can use Dockers as well to install it. Even in my machine, what I have done is I have installed mid server as a Docker, and using the Kubernetes, I am scaling up and scaling down. And the case is something else. Now, when I talk about Windows and Linux, so in market, it's usually a lot of confusion that where they should do it. Should you do it in Windows or should you do it in Linux? So, in case, it's just a thumb rule, okay? In case you are going into a scenario where you have to work with third-party machines which are having base OS as Windows. In that case, your mid server needs to be Windows because Linux has a restriction that it cannot execute any PowerShell command. That's the only thumb rule. So if your end device or third-party device where you are having an integration, if you need to invoke with that machine with PowerShell script or WMI script or Windows based script, then your mid server should have Windows based OS. That's it. Other than that, you can go ahead with Linux as well. Okay. Now I have created a very good animation that there are two people. I'm sure you must have seen this. This is Naruto. This is Sasuke, and they always keep fighting. So Naruto represent our Windows, Sasuke represent our Linux, and they are having this conversation that which one is to use which one to use for mid server. Is it Windows machine or Linux machine? And now they are fighting like hell. So why don't we come into the picture and we try to give them a installation demo that on Windows how it can be done and on Linux how it can be done. So for that, I have taken one instance. Okay, you can take this instance from your you can take this instance from your Now Learning. You can I will create another video that how you can take the instance from on Now Learning to work with your labs and everything. But right now, when you take this instance from Now Learning, they have already set up your mid server. So if you go into the mid server, they have already set up a Windows machine. If I open this Windows machine, though right now it's not validated, we gonna soon validate that machine, and we will also see that what happened once you validate. If you go and if you look into some of the configuration parameter, these are some of the configuration parameters, and I want to show you some more things. It's not there. Okay, leave it. We will talk about that one later on. Now let's say I want to install it on Linux machine. I have a Linux machine with me. So now, if you see, if I click on download, usually before QBack, you have only this download signature option or download option, and usually you were having only 64-bit MSI installer. Otherwise, most of the time we have to download the zip files. And in case of Linux machines where we are not having GUI, where we are having only command line, so it was pretty hectic to install it on to get the URI. Now what need to be done, what ServiceNow has done is they have given us this copy URL kind of stuff. So my machine, this machine is a 64-bit CentOS. Now I can either download the zip file or either I can download this RPM installer. So what I am going to do is I have already downloaded the RPM installer. So you just need to click on this and you just need to wget. So it's command to download it, download any file on Linux machine, and you just click on this. Okay, so I have already done it. So let me ls-l. So you see that this installer is already there. Okay, so what I need to do is I will create a mid test folder, mkdir mid test +-l. So it is there. Now what I'll do is I will go into this install a mid server on Linux. You have to run this command. Okay, you have to run this command. So it's a sudo rpm. Rpm is for RPM devs are on for Red Hat based OS devices, and because my machine is Red Hat based, which is CentOS, so I can utilize that. I'll go with sudo rpm -ivh node ps. So basically this node ps is utilized when you install any of the RPM, it will automatically install its dependency along with it. So our RPM name is mid-linux and prefix with that where I want to install it. So I want to install it in my mid test. Okay, that's my installation directory. Now as soon as I click on this one, it will unzip it and it will ask a lot of things to me. Artifacts prefix should be so now it is preparing. It will take some time. Until the time, I'll open my coffee. So you see that right now it is what it says that mid server has been installed at this folder. Mid server can be configured using installer.sh script. Please refer blah 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 file. Okay, so let's go inside this mid test. We don't have it because we have actually installed it in base directory. So cd. Here is our mid server cd agent ls-l. So now we are having all the things. So either I can go in the old way, I can configure my config.xml, I can do all those stuff. And instead of that, what I can do is I can run this installer.sh. Okay, so let's run this installer.sh. Even before that, let's create one user. Let's create one user. Let's call it as mid Linux. Let's give it password mid at 123. Let's save it. Let's give him a role. Mid server. Basically, it will allow all the important role like REST, so all those stuff. Now let's play with it. So now it is asking enter the ServiceNow URL, HTTP your URL. So our URL is TAC 02186. That's the URL. Do you want to use proxy? No. Do you want to use mutual authentication? Because I am in Quebec instance, this is something new, that instead of utilizing just the username and password to have a communication set up and established between mid server and ServiceNow, you can use the mutual authentication, which is a certificate based authentication. If I do that, in that case, I have to install a certificate in this Linux machine, as well as I have to deploy the same certificate in ServiceNow so that when they communicate, they will match their certificate. Right now, for this demo purpose, we are not going to do the mutual authentication one, but I will create one video for you guys where we can see that how we can install the mutual authentication mid servers as well. Now, waiting for instance validation. So enter the username format. So R1 is mid Linux. Password mid at 123. It is validating this stuff. Username and password are valid. So now it is asking, I'll say TAC 02186 is the mid server name that I have given. Unique name for the service created. So that is pretty important because in this machine I have more than one mid server installed. So if not to clash, so I need to provide a unique name for the service that needs to be created. So I'll give it as TAC 02186 Linux. Okay, that's my machine's unique name. Okay, so it is saying that okay, mid TAC 02186 Linux. Enter the long name of the service. So again, I'll call it as TAC 02186. Enter the non-root username password. I don't. In that case, if you eventually want to use that, let's say I'll give the root itself. Artemis. No. It is basically, it is asking me that if I need to change the permission. Hey, so it is saying that mid is running as a service successfully. Let's say ps-ef. See, mid test agent, it is running up and running. So this is how quickly we can install the mid server. Let's see if that mid server is in our list or not. So now I got my mid server as well, right? So if you see that my mid server, okay, that I have installed, I have not changed any kind of things, okay, in the configuration. So if I open this config.xml, correct, let's say cat config.xml, these are some of the information that is there. So by default, if I have not put any kind of information in this thread, okay, the maximum is 25 it will catch. So these are certain prerequisite stuff or certain pre-configured properties that are already there. This was the name that we set up and all other things, okay. Now even if I try to see if I got the thread information here or not, JVM version, RAM, okay, one more thing. So starting Quebec, your JVM version in a mid server is upgraded to JRE11, okay, that is shipped by default. Now we have installed the mid server, but these mid server will not work at all. Reason, these are not validated mid servers. So I will validate it. I will validate both the mid servers. So once we validate, it will ask, allow all application, all capabilities and all IP range. I'll say yes. In the same way, I will validate this one as well. Save. So we will take some time. See, right now mine one is done because it might be validating other stuff, okay, but this is done. Okay, it's a public key for the mid server. So if you have your authentication as a mutual setup, then these public key and private key will come into the picture. Let's refresh it. It's validating. Okay, this one is still validating. Okay, so till now we have seen that how we can install the mid server. Now how these mid server are actually communicating to each other, okay, that is pretty important, that how mid server is communicating to anyone. Okay, so we need to understand that how the communication architecture work in the backend. Okay, so that's the next stuff for us to learn. We have seen the installation demo. We have to see that how those communication actually happen. So even before going to that, there is one more important place which I want to show. That is ECC Queue. So every communication that needs to happen to a mid server goes through with this ECC Queue. Okay. Now, and this slide is pretty important, okay, and I will help you to understand this slide. Okay, whenever you will create a mid server, there is a AMB channel by default created, and that channel is /mid/server/mid server ID. Let's see if that AMB channel, if I try to open this AMB channel here, if that will work. /mid/AMB, or it's the opposite, mid/server. If it will show me this channel, yeah, it will not show me this channel here in this way. I will show you in another way that how we can see the AMB services. But as soon as I have created a mid server, one AMB channel, asynchronous message bus channel, is created in backend. Now what will happen is that it is my instance, it is my mid server. So in a legacy way, what will happen is, in a legacy way, we have a ECC queue monitor which keeps polling the ECC queue in every 5 or 6 seconds. Okay, that if there is any job for me, But in a real-time scenario, when you are having jobs up and running, what will happen is this legacy way will hinder the performance, okay? Because every time you will wait for 5 or 6 seconds and then you will get your job done. So what happen is that as soon as there is any data point, any record or any job is inserted in ECC queue or inserted or updated, there is a ECC queue DB listener in ServiceNow. What it does, it will push. So basically it will work on a pub sub model. It's an advanced model, but some of the people here will understand this publisher subscription model. So this DB listener, as soon as there is anything inserted in ECC queue related to mid server, it will push one data. Let's call it as a flag for that particular mid server. It will push one flag on that particular AMB channel on that particular mid server that, hey boss, I have one job for you. Now on mid server, what they are having is AMB channel listener. Now what they will do is they will listen that, okay, there is one job. Then this AMB client will go into the mid server ECC queue. Again, it will go into this manner. It will again go to the ECC queue. Okay, give me my job. It will then do the stuff and push back the result back to the ECC queue. So this AMB channel pretty much, this AMB channel will eventually help to achieve a asynchronous and on the fly communication. Instead of having a wait time communication, it is a on the fly communication. Okay, to understand this is a pretty neat and clean block diagram, but to understand in a more deep down format, I have a different diagram for you. So let's say this is my ServiceNow instance, this is my mid server, and this is my external system where I need to have my job and I need to perform some job here. So let's say in one of my business logic, I need to call an API, external system API. So to call an external system API via mid server, we have our own way of calling it. So as soon as I call it, there is a job insert in ECC queue. Now, as soon as there is a job insert in ECC queue, we talked about that on insert and on update ECC database ECC queue listener. So what it will do is it will push an on insert event to a channel, this AMB channel. Now, what will happen is, because on mid server side, someone is listening to this AMB channel, someone is a subscriber, it will get on insert message to the subscriber. As soon as that subscriber listener will get the message, it will poll the ECC queue that give me my job. As soon as it will get the job, all the pending jobs and everything, it will perform the job onto the external result. It will get the response and then it will push the data back into ECC queue, and from ECC queue we will get the result in my business logic. This is how internally the whole structure communicates. Usually this AMB is the main one. Sometimes what will happen is that our AMB is down because of many other reasons. In customer environment, they does not allow WebSocket communication. So this AMB works based on WebSocket communication. So in that case, if that is not there, then mid server will communicate based on your legacy way. That how legacy way we are having. This is how this whole mid server communication architecture is based on. Now till now what we have learned is we have learned common things, how mid server communicates, how to install the mid server, what are the different components, okay, what are the underlying components. We will now understand some of the advanced concepts. Now, one of the advanced concept is your thread. We talk about thread, right? So thread is what? Thread is nothing. Thread is a Java thread. Many of you are come from Java background or any C++ or .NET. So thread is a execution of a program. Okay, it's a single execution module that is working to execute that job. Now we saw that the default thread configuration in a mid server is 25, but you can increase. Once you increase the number of the thread, it means you are speeding up the job of a mid server to execute at a single point of time. Okay, now because you are increasing the number of thread, and thread are residing into a virtual machine, JVM virtual machine. In that case, you have to increase your JVM memory. If you have not increased the JVM memory and you have increased the number of thread, you might get your mid server crashed or your job might stop. That is one thing. Another thing is, by default, mid server JVM memory is 1 GB. Okay, this configuration you can find into wrapper override config file under conf folder. I'll just show it to you where you will find it. So this is an agent, right? So if I do ls-l, you see there is this conf file. If I go inside this and do ls-l, there is something known as wrapper override.config. Let's see the data inside this. So you see that the data inside this is, I'll go up. There is my mid server name, Java, and this is my wrapper Java max memory, that is 1024. This is a maximum one. If I need to change it, what I need to do is I need to uncomment this line and put my new value here. And this is my memory. Now, because once you are having more thread, it means you require more memory, then you have to increase it. Okay, but a single mid server should not go beyond 200 threads. In case of having 200 threads, your maximum memory you have to go above is 4 GB. That is into 4. Okay, 4000. That's one of the practice. That is regarding JVM. Now, that is one important question, because till now you will find all these things written somewhere, but now what I am going to talk about is you will not find it anywhere actually. So how to calculate the performance of a mid server? So when I send a probe or a job to run on a mid server, okay, how many thread? So mid server actually process about a probe per minute per thread. So it's like one job per minute per thread. And usually when you do a discovery, let's talk it about on discovery basis. Usually there are maximum 7 probe per device on an average. Okay, that again depend that what kind of device you might be having, what kind of network communication. But from our experience, from my experience and from others' experience, what we have seen is there are maximum 7 probes that actually work on a device on an average basis. So what I say is that a mid server process is actually a probe execution per minute per thread. Okay, so let's say if my IP range is usually large, let's say 100 or more than that, then your mid server will actually spend a lot of time on scanning non-responding IP addresses. In that case, because your number of probes are more for scanning, in that case you are slowing up the performance. Okay, there are other aspects as well to increase this type of things. I have just put one example here, but there are other aspects like you can have your Sesame probe pattern as a cluster basis. In that case, your performance will increase. You can club the number of IPs, and instead of 1000 and 5000, you can put as 10,000. But this is one formula that you should remember, that a process or a job is actually a probe per minute per thread, and on an average there are 7 probes per device. Okay, because in the next screen, in the next slide, we are going to see one important performance calculator. Okay, it's an example. Let's say in Morpheus, okay, we are having 205,000 devices, and those devices are a mix of servers, network gears, printers, and workstation all together. Now I want to discover, but I have a restriction. I have put a restriction that you have to do this job between 6 p.m. and midnight on Friday and 3 a.m. on Saturday each week. So it means, what's my discovery window? Discovery window is 6 hours. So let's take a step back. Okay, I'll not show you the answer, but you guys should think from this perspective that a process is a probe per minute per thread, and there are 7 probes per device on an average. That how many mid server you will require, okay, or what is the total number of time you will require, how you will calculate that, or how you will calculate the performance. Okay, just take 2 minutes or 3 minutes, work on it, then I'll show you the solution. Okay, time up, only 50 seconds, because it won't require more time. So below is the rough estimation for a single mid server that uses 25 thread to achieve this goal. Let's take a single mid server. So with our rule, what we are talking about is, there are how many probes per device is 7. So with this much of devices, how many probes we will be having? Average 17,500, or I'll say 1800 with 25 threads. So it means mid server can process about 25 probes per minute. Correct? That's the thumb rule. That's the definition. So if I divide that 75,500 by 25, I'll get the maximum time to be done for these devices. Once I divide it, I'll get approx 11 hours. But how much time we are having for this discovery? It is 6 hours. So it means a single machine, if I need to do it via single machine, I cannot do it. And even if I need to do it with via single machine, instead of this 25, I have to increase the number of threads. Okay, instead of doing it with 25, if I do it with the 200, so what will happen is 75,500 divided by 200. Okay, so 200 threads, if let's say I have configured it, so what will happen is 175, it means it will again somewhere around 8 hours. It will again come somewhere around 8 or 9 hours or something, right? Now what will happen, that still doing with 200 threads and probes, we are not able to achieve our window timeline. So we need to have more aspect. Okay, we need to see that how we can have a mid server cluster, how we can, instead of having one machine to work on, how we can have multiple machines to take up the job, right? And that bring up our multiple mid server and job routing. So I showed you that example, and in that example we clearly saw that even if I go with the maximum suggested thread count, okay, we are still not able to achieve that time zone, that discovery window. Okay, so what will happen is that is one case where I need to have multiple mid server, and that will also come with job routing. Another is that instead of having everything in a one data center, it might be the customer is having all the devices into different data centers, and where they do not have a inter data center communication. In that case, I need to have a multiple mid server. There are other use cases as well. Okay, if you are having a MSP instance, so you might need to use your different mid server for different customers. Now, how you can define it? Okay, where are your job routing criterias? You can define it via app based on application. So if you see, if I come here on mid server, if I open any mid server, you see that we configured it, right, while validating it. So we allowed for all the applications, but you can restrict the jobs per mid server based on application, and there are different applications, and those applications are your service watch, discovery, event management, OI, cloud management. And even if, let's say, you are utilizing your own application, you can create your own application, and your job routing will work on that that application basis. Okay, another is IP address and range. You can have your mid server assigned to a particular IP address, and when you are doing any work on that particular IP address, only that mid server will be taken up. Okay, that you need to do in your IP ranges. Right now we have put all, but you can create your own IP range based on customer provided information. And then once you are trying to play with that particular IP, what will happen is system will automatically pick up that particular mid server or a set of mid server to do the job, and will work based on that. Another important aspect is capability. Sometimes what happens is your IP ranges, applications, both are same, but you can have your different capabilities. Like for orchestration, you want to utilize one mid server. For different type of capabilities, you want to utilize different mid server. And in our case, in our SDP, you know that our internal tool, okay, when we configure that, we create our own capability known as SDP, so that those mid server which are having only those capabilities will pick up that job. No other mid server will get clashed onto that one. So these are some of the criterias by which our job routing and multiple mid server work into the system, and those things work together. Now, when we say multiple mid server, so it does not mean that those mid server are staying in a segregated way. No, you can club those mid server. You can club those mid server into two different ways, either a load balancer or a failover condition. Now, when we talk about load balancer, so in a load balancer, what will happen is we balance the work between the mid servers. So let's say there are two mid servers, and one mid server wants to have one mid server is having a lot of work. Then the same criteria, based on the last screen that we have seen, based on that, the mid server again got some other job that mid server needs to perform. If we are having a load balancer clustering, then ServiceNow intelligently will divide the work between two mid servers, so that one mid server does not have too much work. Okay. Another is failover protection. What will happen is that there is a mid server, and that mid server somehow crashed. So the job that is running on that mid server, who's gonna take up that job? That will come under your failover protection. So what will happen is that even these two alone are not a good solution. Okay, that you will just configure the load balancing and done? No. Or you will just configure the failover and done? No. Ideal solution is you combine the cluster. So we will create a cluster where mid server are connected into a load balancer as well as failover mode. We will talk about this one later on, that how it can be done. Okay, but right now just understand that a mid server can be added to both the clusters at the same time. To understand the example, let's say I have created one cluster that is load balancer, where mid server A, B, C and D are connected in a load balancing way. Then we are having a failover, that is mid server D, E, F and G. Let's say and order is 100. So whichever is getting the highest order, that will get the data. So let's say D is down. Okay. So as soon as D is down, and because there is work assigned on this cluster, now the job that needs to be assigned on D is down, and these servers are already having a hell lot of work. So ServiceNow will look into the failover one and it will pick up E because of lowest order. Okay, it will pick up E to assign the job. That is how you can combine these clusters. Okay, probably for mid server B, we might have different failover here somewhere with some different mid servers. In case that if B is down, those jobs can be routed and assigned to those set of mid servers. That is how this combining cluster work. Now we talk about mid server, we talk about load balancer failover, we talk about their combining clusters, we also talk about that what are the different performance measurement and calculation criteria. There is one more important aspect that I want to talk about before we end the session, and that is ECC Queue. We really need to understand the ECC Queue, that what are those components. So actually, when ServiceNow needs to execute any job with the help of mid server, so the ECC Queue record is an output record. The type of record that is created, that is an output record. So what happened is it's a screenshot that I have taken from ServiceNow instance itself. So there will be certain payload. Payload will consider that what kind of information that needs to be executed. Then what is my prod, what is my multi-prop, what are my sources, what is my queue type, what is the state created, blah, blah, blah stuff. But I will explain some of the important stuff. That is, one is agent. See, agent is the name of mid server. So it starts with mid.server. Then name of the mid server. Topic and name is usually about the type and the stuff that you want to execute. Even if you want, you can create your own topic and you can ask mid server to execute that, or even you can directly create an output record to execute a simple command on mid servers. We will see it. Okay, if time allowed, we will see that. Okay, then this is a source where that needs to be executed. Then there are some other different aspects like queue and payload, and when it is processed or when it is created. Once I get this job at mid server level and mid server actually execute this data and perform this job and push back the result, at that time that ECC Queue record is known as input record, because we are getting the input from outside of ServiceNow instance. Once we have that input, it will again look like something like this. Okay. Now there is one more important aspect, that is response to, which is for which output record it is the answer. Okay, and then payload will has this result tag where you have all the results and everything. Okay, now one of the advanced stuff I just want to talk about right now, we will see their execution, their practical implementation in later stages. One of them is loading of the custom jar. Another is custom script files. So let's say there are some of the stuff that you cannot perform in ServiceNow, but you have to do it. Then you can utilize mid-server script files, mid-server script includes, and mid-server jars. Okay. In future, we will have one session where we will see that how we can do that. And in this one, what I have done is I have written down, I have zolled down some of the common issues and troubleshooting steps that we need to take in case of mid server. Sometimes when mid server is down or does not start, it means might be either your firewall is down or your proxy is down. Okay, or probably your mid server was not set up correctly, or sometimes what happen in case of Linux, your JVM corrupt, okay, and sometimes your certification does not match in case of Linux only. Another is your mid server is set up, everything is done, but you cannot restart your mid server. Can be because of there are too many events in the mid server logs, okay, or can be any other reason. I have jotted down some of the best known KB articles which can help. One of the important aspect is your auto upgrade field. Reason we all know that auto upgrade usually fail because from the customer premises we don't have the access of install.service-now.com. Once you give it, it will fail. Another important aspect is that, and that usually come in case of Linux. Usually these things also come into the this particular error will also come into the Windows, but it's very rare. In case of Linux, what happen is because of the security of the folder, the mid server service that is there, that is assigned and that is working, it's not able to, what I say, it's not able to get it's not able to download and write into that folder, and that's why our auto upgrade fail. Sometimes what happen is you cannot log into the mid server, again network issue. And one of the important aspect is that your probe does not work, and this actually happen because of a lot of reasons. Probably one of the reason is your mid server is overflown with your data. Another reason is once you check your mid server logs, there might be some of the Java code that is failing. Another is though mid server is able to get the data, but because usually what happen is that how mid server transfer the data, okay, how mid server actually transfer the file. So if I show you this again, you see that once you execute anything, okay, and mid server perform that job, there is this work folder. All that job result will be put inside this work folder. And sometimes what happen is that ServiceNow was not able to synchronize this work folder to ECC Queue, and that's why your probe does not work, because your probe has actually executed, your job has executed, but the result you are not able to get back into ServiceNow, and that's why your probe keeps failing. You do not get your input record. And there is another log agent one and this KB article that you can use to verify all these type of things. So that's how your mid server work into the system. That's how all the components are placed into the system. And frankly speaking, once we understand all these things, that how communication established between mid server, there are some other important aspect that we will see once we will do the discovery or service mapping one. But that's it for mid server installation and mid server stuff.